We'll cover the basic examples from chapter 17. Right now we have example number 1 from chapter 17. There are LEDs are connected from PB0 to PB7 at the 80 mega 328p. This is the code of example. In this code there is an unsigned character Z. DDRB is set to output. All pins are on because 0xFF in hexadecimal means 1 1 in 8 bits. Then there is a for loop which increases the numbers from 0 to 255 incrementally and running the port B high step by step. Let's compile the code. So let's compile it and build this project from here. And when we run this project, the LEDs, as you can see, they are turning on and off incrementally, and they are kind of blinking in it. So this is example number 1. This is the code of example 3 7.3. As you can see, it is toggling 200 times. The pin B is set to output. The pin B is set to in is set to output, and with this format 10101010 and then unsigned character Z. And by using this unsigned character Z, we are increasing its value from 0 to 200, and port B we are toggling it from 1 to 0. And when we compile it and run it here, it is showing the value of this. As you can see, one is off and the other one is on. So that is example number 3. In example number 2, there is a list. We have created this list with the string value from 0 to D. We have declared a character value of Z and the DRB to take as output. We have declared Z as 0 and we are incrementing the value of Z from 0 to 9 because it is less than, not less than, equal to. So it goes from 0 to 9, takes less than 10 values, and then port B will send the characters to my list, means Z. And when we compile it and run it, this is the circuit, the same circuit which we used earlier. It will take the LED connected at pin 7 and pin 14. As you can see, the LED connected at pin 7 is PB6 and pin 14 is PB2. So it is taking these two values as high and the other ones are off in this. This is example number 2. This is the example number 9. In this code we have declared this thing separately because we have not a separate header file for delay in Proteus. So we have called this function void delay ms, and we called its value at 500. So it means 0.5 second of delay is present in it. First we have declared the DDRB as output, did the whole port 1, and while 1 we are incrementing the value of port B with the increment of 1. After building it, when we run it, it is showing the value of this, incrementing step by step. It is increasing the value, and with each step it is increasing the previous value and so on. So this is the example number 9. This is the example number 11. As you can see, DDRC is set to 0. 0 means input in this case. DDRB and DDRD are both set to output, which means that all of these their 8 bits are set to the output. We have declared an unsigned character temp. We have stored the value of pin C in the temp, and we have initialized an if condition that if temp is less than 100, then the port B equal will be equal to temp. Temp means the port will show the value of temp, and in the else case, if that condition is not true, then the port D will show that value of temp, and temp is the unsigned character of the variable, unsigned character of the variable. After building it, when we run it here, and you can see these are the values of inputs which we are giving it, and these LEDs are the outputs which we are giving it. This code will run as this. Like this is the code. We have changed the inputs and outputs. There was the error in it. Pin D is the input and pin B and pin C are the outputs of it. And the same thing which we did for pin D will do for pin B. And when we run the code, this thing, as you can see, the each logic state is triggering some value here. So that is example number 7.11. This is the example 7.12. In this example, we have taken the port B as output, we have taken the port C as output, and we have taken port D as an output. We have done the AND operations on it, we have done the OR operation on it, and we have done XOR operations on it. And at the pin B, we have inverted it. And this is simple AND, OR, and XOR operations, and simple NOT operators on it. So if we compile this code and run it there, these outputs will show. First there will be AND, then OR, and then XOR. So there is not an input which we are giving, there is only output here, and it is generating the values on its own. So that is example 7.12. This is example 7.17. In this example, we have declared the unsigned character Z, we have declared the port B as an input and port D as an output. We have uh, written an infinite loop here with the while 1. We have stored the value of pin B in Z. We have taken the AND operator of Z with the unused bits of the circuit, and then we have used the switch conditions instead of an if condition. It is used to make the same logical operations as if, but it considers one character or one number, one integer as a condition. In case of 0, the port D will show 0. In case of 1, the port D will show 1, ASCII of 1. In case of 2, the port D will show 2, and in case of 3, it will show 0. There is no default for the switch because we don't need it. After running it, when we play it, so it will show these values, such values which we are going to use in our circuit. So that is example 7.17. This is the example 7.24. In this example, it will take the PB5 as an input and will give the output at PC5. So as you can see, it is declaring the PC5 because we have shifted the value from 5. Right now it is not PC6, it is PC5, and it is pin 29, pin 28 on Arduino, so we have to edit this too. And PC, in this thing it will first check if the PB5 is high. If PB5 is high, then it will make PC5 high, and if it is not high, it will make the PC5 low. So let's run it, compile it. Compilation is successful. Let's run the code and see there's a button connected at PB5 and then LED connected at PC5, and when the button is pressed, the LED turns on. So that is example 7.24. This is example 7.25. First it will declare the value of LED to 5 and the sensor value to 1. It is defined in this, and then DDRB is set as an input, and this value of sensor is stored in DDRB, and the DDRC is set as output because the value of LED is stored in DDRC. Infinite loop is occurred in this, and PB1 is high. If PB1 is high, then the condition is this: PC5 will be high, and if it is not high, then PC5 will be low. And this is a schematic capture. If we run it here, see the button is connected, 5V is connected with the PB1, and the LED is connected with PC5. So if I press this button, then the LED will turn on. So this is example 7.25. This is example 7.26. In this example, we have declared the two variables x and y. Unsigned character, we have declared the value of it. It is 29 hex value to 9, and we have declared both DDR-B and DDR-C as an output because the value is 1. We have stored the value, the AND value of my byte and this F value, 1 bit F, into the X variable. Port B is taken the OR between X and this value, and Y is taking AND of my byte and 0xf0 value first, just like we did for the X, and then the Y shifted 4 values to the left side of it. Port C is then taken the OR of Y and the value 0x30, and if we run this program, as you can see, we don't have to connect anything. It will give these values at port B and port C. So that is example 7.26. This is example 7.31. As you can see, we have declared 5 variables in it. First there is X, then bin byte, then D1, D2, and D3. We have declared port B, port C, D both to input, and after it bin byte we have used this value to store in it. Then we have divided the bin byte by 10 and stored this value in X. Then we have taken the remainder of bin byte with 10 and stored this value in D1. Then we have taken the remainder of X with 10 and stored this value in D2, and then divided the X with 10 and stored this value in D3. Port B, we have said that okay, we want to store the value of D1 to port B, and then do D2 into port C, and then D3 into port D. And after compilation, when we run this program, it will show these values. It is 1 1 0 0 0 0 0 0. At the moment it is 1 0 1 0 0 0 1 at port C, and port D it is 0 1 0 0 0 0 0 0 at port D. So that is example 7.31. For example 7.27, we have these values. First we have taken the unsigned character BCD byte. We have stored the character value of 4 in unsigned character W. We have stored the character value of 7 in unsigned character Z. DDR-B is set to the output because all of its values is 1. We have taken the AND of W with its own W and with this number 0x0f, and then we have shifted the value 4 from the right to the right into the W and store it in W, and after it the Z is equal to Z and with the value of this 0x0f. It is, and 0x0f is the value of 1111, and 0f means 0000, so that is the value of 0x0f. BCD byte, we have taken the OR value of W and Z, and after it we have stored the BCD value into the port B. When we build this program and run it there, it will show the value of PB0 111 000 10. So this is the value of PB of port B. This example 7.27. This is the last example 7.31 or 7.34, the last example. So first we have defined the serial pin 3 in this, and unsigned character is we've taken the X, and then we have taken the register value of 0. It is basically the internal working of the registers in this, and to show the internal workings we have used this thing DDRD as an output, and we have stored the value of internal register A in the port D, just because we want to see what is happening in the inside. So that was not in the example. We have added these two lines just to show that the process happening in the register A. DDRC is set to this, and we have taken the for loop. We're incrementing the value to 7, and at the value of 8 the for loop will be terminated. We have shifted the register A one value to the left side and stored this value again in the register A. After this line will be executed. Pin C will be taken and with the serial pin, and serial pin will be right shifted with the value of 1, and after this value, this entire process, it is then shifted to this value 7 minus serial pin. The value which we have stored in the serial pin is this. So after it, just to show the value of register A, we have added this thing port D, and the value of just array will get shown on this board. If we run it here, and as you can see, PC3, if we take this one and run the code, the entire port D will get high, and no matter if we change it or not, it will remain high as long as we turn it off. Now let's turn it off, and the value of PC3 is 0 pin 26, and then turn it back again. So as you can see, it is 0, and no matter if we change it or not, it will remain 0. So it entirely depends on the value of PC3 on the startup. So that is example 7.34.